on the x-axis.
So in other words, when the what? When the,
in other words, when the x decreases by 1.
When the x what?
Decreases.
With respect to one, let's go back up there. Let's go back.
When the x increases, increases x and y up there.
Right. X with respect to one always
when the
increase.
X increases, the y decreases.
Right. Always increase. When you're talking about the x, always an increase. In other words, when the x increases by how much? By 1. What happening to the y? What's happening to the y? I need somebody else. Anybody else? This is very important at the definition of gradient.
So it decreases by 10.
The y decreases by 10. So that's why when you see you have a negative gradient, the line is going down. Okay. Now let's talk about the y-intercept. The gradient is given the letter m. And the gradient now is given the letter c. What can we say about the gradient, the y-intercept? It is the y value when the what? What letter am I writing right there? When the, anybody? It is the y value when the
y, when the line crosses the y-axis. I don't know.
When the x is equal to what?
0.
Is equal to 0. All right. In other words, it is the point at which the line crosses the y-axis.
Y-axis.
Always remember that the x value
is always 0.
Is always what?
0.
0 where?
The line crosses the y-axis.
The x value is always 0 on the y-axis.
Yes.
All right. So anywhere on the
So
y-axis.
0,
all right. So therefore now the point is always
0, c.
Let's put a p there. 0, c. Okay. Bear in mind x, y. On the y-axis, x is 0. 0, c. C will be the y value. So let's just bring this up to see if that can go on one page. That's number 9 right there. Don't have to be so clear. Right. So now what we have here now is an example similar to number 9. It says a tank is being filled with water. The volume of water V liters in the tank after 10 minutes is given by the linear equation V is equal to 2.8 T plus 6.7. What is the initial volume of the tank? What is the rate at which the volume is changing? How many liters of water is in the tank after 8 minutes? The maximum volume of the tank is 50 liters. How long will it take to fill the tank? Right. So, solution, part 1. The term initial implies that time t is equal to what? Help me out.
0.
Please bear that in mind. Associate, when you're doing a question like that, associate the word initial with the value 0. All right? 0 for the x coordinate. Okay? So the term initial implies t because t takes the position for x and v takes the position for y. All right? We have to put it side by side. This is like y is equal to mx plus c. Okay? And y is like v and x is like t. So initial implies t is equal to 0. Don't forget the question. Somebody has their mic on and it's competing with my voice. Hello, somebody has their mic on and it's competing with my voice. Yes. It says, what is the initial volume of water in a tank? That is the question. What is the initial volume? The term initial implies that t is equal to 0. So hence, what do? We're trying to answer the question, what is the initial volume? Volume is a V. What is the initial volume? Is a V we're trying to calculate. All right. So answer have to be in liters. Or answer for part I have to be in liters. Initial implies t is equal to 0. And substitute, what are we to substitute? Help me complete.
T is equal to 0.
And substitute t is equal to 0 in the place of time and evaluate for v. Therefore, I put the initial equation there and I put 3 dots coming down. I need some help. How can we proceed?
V is equal to 2.8.
V is equal, exactly, V is equal to 2.8, open bracket 0, plus what?
6.7.
6.7. V is equal to what?
6.7.
6.7 liters. Any questions? So you apply that to number 11. Number 11 is very similar to number 9. Number 10, sorry. Apply that to number 10. Part 2, what is part 2 asking? What is the rate at which the volume is changing? We just spoke about rate a while ago. Anybody, what does the word rate reminds us of?
The gradient.
Gradient. All right. Oh, so here let's complete it. The hence, let me put the hence there, or therefore. Comma. The initial volume of water is 6.7 liters. The term rate is synonymous with the word, what we said again, with gradient.
The gradient.
And when somebody speak, when you speak, as soon as you finish speak, mute your mic, please remember to do that. Yeah. So since the gradient in V equal 2.8 plus 6.7 is, help me complete. What is the gradient here?
6.7.
Someone said the gradient is 6.7. Does anybody agree or differ?
2.8.
I would say 2.8 is T.
2.8. So since the gradient in V is equal to 2.8 is 2.8, or let me put M is equal to 2.8. Just make it look a little, our 2.8 by itself there. All right. Therefore, what it says, the rate, right, which the volume is changing is what?
2.8.
2.8 every what? Every what? What unit are we talking about there?
Every minute. Every
minute. Remember the definition, right? The gradient is every time the x changes by 1, the y changes by the gradient. The y there is volume, and the time there, the x there is time. All right, every minute. So every minute the volume is changing. How the volume is changing? Let's say put another description. What kind of a change?
An increase in
Increase. Exactly. 2.8 is a positive. So every time 1 minute pass, the volume increases by 2.8. So please get that clear. Okay. In other words, every
1 minute.
every 1 minute, exactly. That's the definition of gradient right there. Every 1 minute of elapsed time, the volume, continue,
Increases by 2.8.
2.8 what? Liters.
Liters.
Part 3. What is part 3 asking? How many liters of water is in the tank after 8 minutes? By the